Here's some more problems from section 10.1. This is number 11, and again we want to find dy dx, and then we want to find d squared y dx squared, or the second derivative with respect to x. So we've got our two parametric equations, x equals t squared minus 3t and y equals t cubed. So we just find dy dx by taking dy dt over dx dt, and wasn't too bad because dy dt was 3t squared and dx dt was 2t minus 3. Then if we want to take the second derivative, we've got to take the derivative. This is the formula, so I wrote them down this time. So we take the derivative with respect to t of dy dx for the numerator, but the denominator is just dx dt, so we already have that. So that's our denominator. That stays the same, so I take the derivative of this. And I'll have to use the quotient rule, so I kind of did that separately over here, so you can see this over here. So the derivative of the numerator is going to be low d high, low d high, less high, d low, the derivative of 2t minus 3 is 2. Denominator squared below. Then I simplified this. Use the distributive property, 12t squared minus 18t, and then minus 6t squared. Again, same denominator squared below. And then 12t squared minus 6t squared is 6t squared minus 18t all over this. So we went back and put it back into the work up here. So d squared y dx squared equals, this is the numerator, that's the derivative of, with respect to t of dy dx. And then this is d dx dt. And then we could just invert and multiply like this, and this is what we end up with. So some algebra there, but just to simplify it. Okay, number 13, a little more trig work here. There you go. And these are our equations. X equals tangent t, y equals secant t. So here was our formula for the derivative dy dt over dx dt. So dy dt was just a secant tangent. Dx dt was secant squared. Secant squared over secant, or secant over secant becomes 1, so we have tangent over secant. And the tangent is the sine over the cosine, and the secant is 1 over the cosine. I multiply the top and the bottom as a complex fraction, multiply the top and the bottom by cosine of t, end up with sine of t. So that was easy. And then for the b part, we want the second derivative. So here's your work here. The derivative with respect to t of the sine of t, that was easy. And the denominator we already had, dx dt. Well, the derivative of the sine is the cosine, and the secant squared is 1 over the cosine squared. So I again have a complex fraction, multiply the top and the bottom by the cosine squared. So I can get rid of this and make it just 1 in the denominator, and the cosine times cosine squared is cosine cubed. So that wasn't too bad. And then number 15, the natural logs. X was the natural log of 2t. Y was a natural log of 3t to the fourth, so we just bring the 4 in front to make it a little bit easier. Use the property of logarithms. And then dy dx was dy dt over dx dt, so dy dt was just going to be the 4 times 1 over u du, or 1 over 3t times 3. So 3 over 3 is 1, so we just end up with 4 times 1 over t. And the denominator, we just had 1 over u du, or 1 over 2t times 2, so that just becomes 1 over t, but 1 over t becomes 1, so we just have 4. Then we take the second derivative, we take the derivative of the top over just dx dt, and we take the derivative of dy dt for the numerator, so that's d dt of dy dx. So I should have said dy dx, I hope. So take the derivative of dy dx for the numerator, and dx dt we already had was 1 over t. Well, we're going to take the derivative of 4 all over 1 over t, but the derivative of 4 is 0. 0 over 1 over t is 0, so that was our second derivative at 0. Okay? So those were a little bit easier than 9 or 11. Okay? Hope that helps.